Hi, everyone. We're going to get started. So the package demo now is Qian Liu, who's an assistant professor at Roswell Park and is going to talk to us about common workflow language and bioconductor. Yep. And just a reminder, if you're on the platform, to use the Q&A, and I'll moderate those, bring those up. And if you're in the room, you can just raise your hand at any point. Thanks.
So thank you for coming. So maybe I just, oh, yeah. So first I'll share a link to my slides in the morning. I give a short talk. And so when you click on the session of RcwL pipelines and on the helping platform, I will share my slides. Join units, let me try. Let me just paste that to the, I'll just paste to the, I don't know, general.
Yeah,
can I send you?
For you? Yeah, just put it somewhere and I'll
okay, yeah. But I put down the general.
Okay.
Okay.
Got it.
Great. Okay. Hi, everyone. Thank you for coming to my package demo. First, I want to give you the link for this the materials, the evaluated materials that you can just walk through if you can catch up. So it is if you go to RCWL, if you go to rcwl.org/RCWL workshop, and then you will get to this page. And if you click on the articles, and I click here. So this is the evaluated version of the workshop. So you see all the evaluated code over here. It'll be easier to follow. And also, Qian, who is co-presenting with me, he's a major developer of these packages. So if you have any questions, you can ask him directly. He's heading in that corner, is raising his hand. And if you feel bored, just go talk with him. And as Michael is also monitoring those online questions, and he can answer some questions maybe in real time. Okay, yeah, okay, I'll get started, sorry. So today I talk about how to use R to create and execute reproducible CWL workflows for genomic research. So I give a short talk this morning for using like 3 bioconductor packages: RcwL, RcwL pipelines, and reuse data for the reusable and reproducible genomic data analysis and management. So I will do the demo based on these 3 packages. So for an overview, here are the packages that are going to be used in this workshop. A variant annotation is a package, is a very, very valuable package for variant annotation as a bioconductor package, which will be used as like a downstream R package after our packages. So I will demonstrate these three packages. RCWL as an R interface for CWL, common workflow language. And RcwlPipelines is built based on the RCWL, which catalogs more than 200 pre-built bioinformatics tools and best practice pipelines in R. And those pre-built tools and pipelines are very easily customizable to fit your own need. And I will also talk about the reuse data for the management of the reusable genomic data, such as the reference genome file and data like variant annotation or gene annotation files. So for this workshop, we will implement the variant calling workflow within R using the MuTag 2 from GATK. And this whole workflow is based on the R programming language and can be deployed in local computer, HPC, and cloud computing platforms using different settings. So with these tools, we should be able to conduct reproducible data analysis using the commonly used bioinformatics tools, including command line-based tools and R bioconductor packages, and validated best practice workflows based on CWL within a unified R programming environment. So for the somatic variant calling, we need to prepare data and tool. It's easier to go over here. So there will be experiment data in format of BAM and index BAM.
Here.
Yeah, the last, this one. I think. Okay.
That's good, thanks.
So by using these two packages, we take advantage of all the existing benefits of using workflow language, like the reproducibility, the more efficient, and you have like, I would say, like most of the people here are using R, so it's a bit, it's more user-friendly, I would say, and it going beyond the CWL, it makes easy connection with the downstream analysis tools in R and Bioconductor, because it can also, you can, besides wrapping a command line tool as a RCWL tool, you can also wrap our Bioconductor package or Bioconductor, the R function as a tool. So they can be connected to run your whole workflow from the beginning to the end. So here, sorry, these are not the most updated version, but I will show you how to run the variant calling using MuTag 2 within R. Okay, so RcwlPipelines includes more than 200 pre-built tools, such as the very commonly used BWA for DNA read alignment, the STAR for RNA read quantification, MuTag 2 for somatic variant calling. You can just search on the rcwl.org. If you go to this website, and go to the RCWL pipelines, you can get a list of all the existing pipelines. Actually, we are not, so next we will make it all the tool recipes available here, but currently only have the pipeline recipes. Just click on one of them. You can see what this pipeline includes, like 2 steps for doing the data analysis, connecting. These are the inputs, and this will be the outputs. You just feed in these input files into the whole workflow, and you will get your desired output. So let me go back. Okay. So there are basically 3 core functions: CWL update, CWL search, and CWL load, to update, search, and load the needed tool or pipeline in R. So I'll go back to my session and do some code running. So actually I have just did something on my computer. If you are already here, if you haven't, you can just run this code of chunk to create to create a folder for our demo. So you can find it in the vignettes folder here in RcwL demo. So I just created this folder, but you will be walk through how to create this. So next there is the CWL search function. So once you do the next you need to do the CWL update. So it will sync the existing tools and workflows from the RcwlPipelines package, and then you will be ready to search the existing tools. So CWL search MuTag2, as we can see, there are multiple pipelines or tools include the MuTag2 tool. So the PL means pipeline, and the TL means the tool. So for example, the PL, the MuTag2 PL over here. So we can just plot this CWL to see what are included. Object MuTag2 PL. Let me do this again. So MuTag2 PL plus. You need to load. You do need to load that tool to your R session, and then you need to. I'm sorry. It should be PL. MuTag2 PL. So it showed MuTag2 loaded and some other tools loaded together. And only, I'm sorry, it doesn't look pretty, but I'll show you how to. So if you go to the rcwl.org, the RcwL pipelines, and you can actually click on the MuTag2 PL and have a better vision of that plot. Like there are multiple tools included in this pipeline. You just need to fit in your data here, including your experiment data and your the public reference data and some like values for the other arguments for the tools, and you can get your output directly. Okay. So we don't want to show you the complex pipeline, like including so many tools. So in this workshop, I'll just show you the simple tool of TL MuTag2 for the variant calling task only. So we can customize the tool by using a smaller Docker image, for example, for the demo purposes, because the default Docker image is pretty big. I'll just show you those advanced functions to customize the existing tools or pipelines. So I think we already loaded it. And if we can see the requirements for MuTag2, you can see the Docker requirements comes with the Broad Institute GTK latest as the default. They always use the latest as default. And we can search a container using the search container function. It's also a function included in RcwL package. So we can see there's a new Docker image. I'm not, okay. I don't use the RStudio a lot, but we can see there are so many Docker images available from GTK4. So we'll just use the require Docker DS1. And then we can look at the requirements again. So now we use a much smaller Docker image. So it's quite simple to customize the existing tools by using a different Docker while taking advantage of the work we have done for the pre-built pipelines. And now we have the tool loaded, and it's called Mutec tool, right? And we can take a look at the input parameters that are required for this tool. And then you need to feed those values to these inputs. So there will be TBAM file for tumor and NBAM for normal, and reference genome, the sample name of normal, the PON file, and the interval. We need to the capture region interval file. So you can see some arguments come with the default values, so you don't need to write repeatedly every time, because like the file name or the folder name can be pretty fixed. So next we will need to assign values to the input parameters before the evaluation. For experiment data, we have prepared a small DNA-seq data for the demo purposes. And now I'll just evaluate this. So it's because I have did the dev tools load all, so you should have access to the system file that are included in the inst.ext data tumor BAM. So just assign the file path to that parameter for TBAM, and assign the file path to the NBAM parameter, and the normal sample is NA12892. The output VCF file, we just use an arbitrary file name for here, use the somatic.vcf. This will be the major output. So we also write a capture region, and we assign the capture region's file path to the interval parameter. And now let's check back to the inputs again. As we can see, these file paths are showing here for different arguments. This is the value for the normal. This is the value for TBAM, value for the NBAM, and the file path for the capture region bed file. And we are still lacking some of the values, for example, the PON and the reference genome. Because these are very reusable genomic data resources, I do want to share with you another package called Reuse Data to show you how to effectively manage this reusable genomic data files, so that you can be more efficiently sharing the same data set with your colleagues, especially if you're working in a bioinformatics core, for example. You can share with your colleagues so that you don't download your separate copies of those files, and you don't need to do the same data processing every time you do different projects, because they can be used in all the DNA-seq. For example, the reference genome can be used in all DNA-seq data analysis, RNA-seq data analysis. So if you already have them, you don't need to use reuse data for managing them. If you already have them, you just assign the file path over here to the Mutec2 ref in parameter and the PON parameter, and you can call the run CWL function. Now you are ready to so this the run CWL function will just submit this submit this R workflow R tool, which are internally submitted as a CWL script. So it will generate all your needed results output to your user specified output directory. And the Docker images can be different based on different computing platforms. But here I'm not doing it because I will show you how to use the reuse data to manage these two tools. We'll come back here in a little bit. So prepare the public genomic data resources using our reuse data. So reuse data basically facilitate the transformation of a shell scripts for data preprocessing. For example, download the wget data from web resource and index data. So downloading and some pre-processing of the public genomic data. So it will facilitate transformation of the shell scripts into a workflow-based data recipes. So they're called data recipes. So the evaluation of the data recipes generate curated data files in their generic formats, such as VCF, BAD, with automatically generated meta files, which will help track the data and tool provenance for subsequent data reuse. We have also previewed some data recipes, but it's not comparable to the RcwL pipelines because the tools are fixed, but the data processing are very different for people's use. But this will just serve as a template for you to build your own data recipe. And but they are ready to be queried and used directly with the reuse data package. So just a little bit about the data recipes. The most common case is that a data recipe can manage multiple data resources with different input parameters. For example, we have a data recipe called gene code transcript. I can show you really quickly. If you click on the data recipes in the website, thinking which I was talking about. The gene code transcripts, okay. So this transcript is going to download, unzip, and index the transcript files from gene code. So the two input parameters are species and versions, and to fit into the data recipe, and you can get your desired transcript file based on your specified species and version. And there's some explanation about inputs and explanation about output. So it will just capture those transcripts.fa and transcript.fa.fai files. And I have some demo code for you to try out this data recipe. I'll come back. So for example, in this recipe, it downloads, I just said a simple, it can also be a simple data downloading task for a specific file. It can also be written as a data recipe without any input parameter. So for example, the GCP GATK muTAG2, GCP GATK muTAG2. Okay, for this recipe, so the file name and IDX is already pre-specified. So let me just show you the raw scripts, but so you don't really, so this recipe doesn't include any input parameters. So you just evaluate, you can just evaluate the data recipe. It will just download the files that are, you can just download the genomic data resources from the GATK resource bundle on the Google Cloud bucket based on the reference build of B37 or HG38 separately. So I have more details. You can go to this link to find the available resources on their website. So in this workshop, we'll just use this simple data recipe, which doesn't require any input if you just download the specific data that we need for this workshop. So we have 4 core functions very similar to the RcwL pipelines: the recipe update, the recipe search, the recipe load. And after this, we need to assign values to the input parameters if they exist, and then we can just render that data recipe to download the data to your local machine with automatic tracking and use the specified nodes or keywords. So just do the library reuse data and do the recipe update. So it says updating, you have 15 records. That's what we have pre-built for different data processing recipes. And oh, I'm sorry. This one do have those input parameters. So let's load this recipe. So now it's available in R due to the cancel. So it's the CWL process S4 class in R, and have some necessary information that you don't really need to know. But you can also return different sections of those information for this recipe. For example, you can use the inputs function to return the input parameters, output, and also the requirements for the Docker image it used. Let's do some downloading. So we just assign the file name, and we assign the index format, and we evaluate the get data function by specifying the file path of your output data file. So here I'm using the work directory, which is the directory I just showed you, the directory in the under the VNet folder. There's a directory called Rcwl underscore demo, and we create a shared data folder, and you can specify your own notes, like anything you can specify here. It will help you find the data later. And okay, so it's success. The final process data is success. List of length, okay. So if we click on the share data, we can see the GCP GTK MUTAC2 B37. What did I download? The exome panel, right? Okay, the exome panel VCF, the exome panel, the VCF.idx are downloaded in this specified folder. I pre-downloaded the other parts, but I'll show you how to do that. Okay. You can check the output. So if we list those just generated data files, we can see the MUTAC2 exome panel.vcf is already here. So these two files are the two files that we need for the MUTAC2 RcwlPipeline pipeline. And at the same time, you can see some annotation files. These files are automatically generated for the data tracking. You don't need to know this, but they will help you manage the data later. So I have a section called for developers. In the very late part, it will explain. If you go to the for developers section, it will explain to you how the data annotation files stand for. Like there are different, there are 4 files. They represent different stuff for the data management. Okay. So now we have the exome MUTAC2 exome panel ready, and we do need to some other file from the same folder. So I'll go to the next code chunk. So we just reuse this data recipe for some other files. So we assign the value for the file name again. So this time it's going to download the reference genome files. Where can I go back? Must lost something, but you should have it. So if you assign values for the file name and the IDX with the file, and you evaluate this function called get data, and to save the data in the same folder, the share data folder, and you should have it available over here. So it should be the Homo sapiens assembly 19.fasta. Yes. Because this view, the reference genome is really big, so it will take about 1 to 2 minutes to download the file. That's why I did it beforehand. So you should have them And you can also do the dict file. This is easy. This is easy. It's really quick. And if you list your files again, you will see them. You already see them over here. You will see those the public genomic resources downloaded together with the annotation files that you don't need to know. And now we are ready to run the MuTag2 tool in R. So how to retrieve the data that you have just downloaded? So there are two core functions to manage the data locally for easy query and use. The data update function is to cache the data in specified data directory, which works recursively. You need to call this function for the first time use, or if any data sets are newly generated with the get data function. So you all need to do this function and use the data search to query any data using multiple keywords. That can be the keywords for the file name or the user specified nodes when you evaluate, when you call the get data function. So I will do data update for the directory of work.dir. To go up. So the work.dir is the RCWL _ demo. So all the data in here will be archived using a local cache. So you can use the data search function to. So we see RS1. So we use the keywords MuTag2 to search the data, and we use another keywords called reference to search the data. We can see what they look like. So the SP search one. So you can see like two data that are having the keyword of MuTag2. These are the exome panel files. You want to know, now you have this data, you need to retrieve the file path for this data so that you can use this data inside R. And when you do the search of number 2, you got some other files that you will be needed for your MuTag2 data. So you just need to retrieve this file path, which can be done using those convenience functions. Okay, so except for the existing keywords like you have assigned to your data, you can also add some additional keywords. We call it data tagging. So you can, because the RS2 only returns the MuTag2, RS2 only returns the Homo sapiens. If we tag this Homo sapiens assembly FASTA file with another keywords, MuTag2, and then we can use the keyword MuTag2 to return like the reference genome at the same time. So I will just add a tag for this reference genome data, and I do the data search again using MuTag2 keywords. Now we can see the RS returns not only the MuTag2 exome panel file, but also the Homo sapiens assembly FASTA file. Oh, okay, I didn't do it. Let me go back. So when I do the get data, so now I have a new data generated. I need to do the data update because I have new data here. So I have data update so the new data can be cached. And we do the I'm going to do the search again. You see the RS2 look like this. So the RS2 search returns like the dig file, the FAST file, and the index FAST file for the assembly 19, and then we add tags for them. Now this data search function returns like all the files that we need for the MuTag2, although the MuTag2 was not originally tagged on this file when you generate this file, but you can just use the data tag to add additional keywords for it. This will be useful if you want to feed your data into a specific software tool. So you can tag all the needed files with that same tag with your software name. That'd be easy to retrieve. And we can use the data path function, which takes the RS, the data search output, as the input. So you can retrieve all the so we can retrieve the RS1. So the ref will be, we can retrieve the file path for the reference genome file. And you can retrieve the path for the panel of normal receive file. So now we can go back to our Rcwl pipelines. Coming back to the tool recipe, here we can assign these values to the tool for the reusable genomic data resources that are managed by Reuse Data, and evaluate the tool using Rcwl for reproducible data analysis. Let's take a look at the inputs of the MuTag2 tool recipe from Rcwl pipelines. So we have fed in some values for TBAM and then for some of the parameters, and now we can assign values for the ref and the PON. Then we are ready to go. Take another look at the input. Now we have the reference, the value for this argument, and now we have the value for the PON. Okay, so the magic function is run CWL. There are some other functions to use to run parallel, but basically you can run CWL, feed in the MuTag2 the tool recipe name, and specify the output directory that you want your somatic variant receive file to be located at, and let's do it. Because I have the show log equals true, so you can see the real-time implementation, real-time evaluation of this recipe. Okay, it should be successful. All the outputs can be found in your specified output folder. Most importantly, the somatic.vcf file. So we can just, here you see the output folder automatic generated. If you list files, you can see the results VCF file for your variant calling. So yeah, so this is how the Rcwl pipelines and Reuse Data works for running a previous command line based tool inside R. And I'll also show you how to use the data within R. So there can be different ways. So you can pass your data to the R Bioconductor packages very easily. You just library variant annotation and get a file path, and you can read VCF. So it can be easily passed to R Bioconductor packages. And they can also, we have also enabled some convenient functions to help you prepare your data output for some standard input formats such as the YAML or JSON, to be easily integrated into the workflow methods that are locally or cloud hosted. So you may need to edit the key of the data values, but we do the data update, the data search. So when we do the data search, we can see it returns like a data hub object. So this is the data search result. So it shows the 5 data sets that will be needed for example, if these files can be fed into another like a workflow script, you can just convert this data search output into a JSON format, and you can also specify the file path for the to be generated data. So as you can see, the file is saved as this file, and it reads as this. So it give you the standard format of like JSON or YAML, so that you can easily pass them to a CWL script, and you can, or a Widow script which requires JSON. You may need to modify these key values for your workflow input parameters. Yeah, basically that's what I wanted to show you. I have some further sections for developers if you're interested in those data annotation files, the implementation of reuse data, and also for you to learn how to create a data recipe. And I have included some links for you to some example template data recipes to help you understand how the package is going to work and how you can build your own data recipe. And also, if you want to know how to create a tool or workflow recipe, you can go to I have some resources listed here, but you can also check out my slides I just shared. There's some screenshots of like some pseudocode showing you how to build your own tool or workflow recipe. If they are not already included in our RcwL Pipelines catalog, you are welcome to contribute to the RcwL Pipelines so that you can share with the other people. That's it for my package demo. If you have any questions, you can just speak directly. Yes.
How does the learning curve for creating your own workflow here compare to some of the other workflow managers like that already exist?
If you already use R a lot, like they're just R functions. Let me see if I can click on the link. I don't, here. So it's just using some R functions to create the tools or recipes here. Where? Not here, not here. I used to have another slice for the demo code, but it's not included here. But basically, you just use these functions to like you specify the base command. It's very similar to the CWL. What CWL takes the base command, the inputs for your software tool, the outputs to be captured, and now you need to define the CWL process and need to define the CWL workflow using different functions. Basically, these are the functions required for you to build your own tool. I would say it'd be easier for the like our users if they want to do it.
Any other questions? The online audience has applause and thumbs up.
Oh, thank you.
Don't have questions.
Awesome. Thank you so much, everyone.